Hi to all. I am Tamil Arasu, Assistant Professor, Department of Mechanical Engineering, K.S.Rangasamy College of Technology, Tiruchendur. I am going to present PPT on the topic of kinematics of machines. First, kinematics. Kinematics is a study of motion without regard or consider the forces. Without consideration forces, we can calculate the kinematics. With the consideration of forces, it is known as kinetics. Next, machines and mechanism. Machines and mechanism. Okay, mechanism is nothing but uh, we can convert from one motion to another type of motions. It is known as mechanism. Machine is converting from one energy to another energy. It is known as machines. Next, it is a mechanism. Okay, in lift platform, we can lift the heavy weight by using this mechanism. Okay, by using jockey or lifter something. Okay. Next, it is like a front loader JCB. We can change then any angle by using mechanism. Hydraulic jack. It is an it we can convert it from one motion to another motion. We can change by using mechanism. Okay, this is a three point binary element 1, 2, and 3. Okay, we can change the change the weight from one place to another position. Okay, it is a binary. Okay, it is a ternary 3 points, same like that. Next, machines. Machine is converted from one energy to another energy. For example, it is a petrol by using converting motion to transmission motion. Okay, and by using rotary, it will convert from rotary motions. Okay, it is a machine, it is a blender, same like that. It is an automatic transmission systems. By using reciprocating motion, it will be from reciprocating motion to it will convert in rotary motions. Next, link. Each part of a machine which moves related to some other part, it is known as kinetic link or element. Each part of a machine which moves relative motions. That means even every motions. That means when it is a crank, okay, it is a crank, or will be in round shape, or it is a single joint. It will rotate. Okay, the link will be rotated in clockwise or anti-clockwise direction. It's no problem. It is a connecting rod. It is a small ended bearing. It is a cross head. It is a piston. Okay, by using it is a double ended piston. That means 1 and 2. It will be connected to another piston. Okay, that means another cylinder. Okay, if the link is rotates in clockwise or anti-clockwise any direction, that's no problem. The piston moves forward and backward, same like that. Okay, if the piston first piston moves backward, it will also that same piston will moves backward. If the piston moves forward, the same piston will move forward. Okay, it will be worked within high speed. It is known as there is some relative motions. Okay, some relative motions across the engine. Okay, it is an engine. Next, types of link. First, rigid link, second, flexible link, and third one, fluid link. First, rigid link. The rigid link is one which does not undergo any deformations while transmitting motion. Okay. First, there is no any when the transmitting motion, there is no any deformations. Okay, it is known as rigid link. This is the power transmitting motions. Okay, this is a rotary. Okay, it rotates clockwise or anti-clockwise. It is a connecting rod. It transforms from one type of, that means rotary, to transform motions. Okay, reciprocating motion, but without any changes, without any deformations. Okay, it is known as rigid link. Next, flexible link. The flexible link one which the path deform in manner is not to affect the transmission of motion. For example, belt, rope, chain, and wire. It is a it's by using by transmitting power, it can be deformed. Okay, it is known as belt. It is known as flexible transformation. So for example, belt. Okay, belt can transmit from one shaft to another shaft. Okay, we can transmit power from one shaft to another shaft by using belt, but it isn't flexible. Okay, flexible means it can expand or retain. Okay, but it can be transmitted. Okay, it is known as flexible link. Next is a fluid link. Fluid link is one which is formed by having a fluid. The motion is transmitted through the fluid by pressure or compression. Okay, in JCP, okay, in JCP, full of oil. Okay, oil can be full of pressured high with a high pressure. The movement will occur. Okay, by with an we can transfer the load from one place to another place. Okay, it is a fluid link. Okay, oil. Okay, example for fluid link is oil. Sorry, JCP, jack, brakes, etc. In hydraulic brakes, we can apply we can put a brake with a pressure. Okay, it tends to press the brake. Okay, it will stop the vehicle. Okay, it is known as fluid. Next, mechanism. When one of the kinematic chain is fixed, the chain is known as mechanism. Okay, when the two links are fixed each other, okay, it is known as kinematic chain. Okay, and also it is known as mechanism. It may be used to transmit or transformation motion. Okay, it can be transmit power, or another ways it transmit motions. Okay, anything. Okay, a mechanism with four links is known as a simple mechanism, and the mechanism with more than four links is known as a compound mechanism. When the mechanism requires to transmit power in to do some particular types of work, it became a machines. First of all, we wanted to know what is a simple mechanism. Simple mechanism is having four links. Okay, for having four links, with help of the four links or more than the four links, then only we can mechanism will be work. For example, if the link have below three links, that means three links. Okay, there we could not give input to any link, or otherwise we could not uh, transmit mechanism. Okay, so if the simple mechanism start at the four link. It is known as a simple mechanism. Next is a compound mechanism. The compound mechanism is having more than four links. It is known as a compound mechanism. It having five, six, seven, something, etc. Okay. Then the number of links are joined together. Then it forms the machines. Okay. For example, it is an engine. Okay, we can give the fuel and the spark. Okay, when the piston, okay, spark is just flattened and the piston moves front and back, then the power is transmitted from here to here. Okay, just it is an assume it is an engine. Okay, front and back, then the transmitting motion is converted into rotary motions. Okay, then it is a then n number of links. For example, this is a first link, the piston is second link, this is the connecting rod is a third link, and the rotary is a fourth link, and the shaft is a fifth link. Okay, there is an n number of links are available in the compound mechanism, then it is known as a machines. Next, machine and the structure. Machine is a device which is receiving energy in some available from utilize it to do some particular types of work. Machine, machine can just it is a simple machine can transmit from power from one form of energy to some another form of energy, but the structure can transmit only force. They just holding the load. Okay, well, like an railway bridge and a roof stress. Okay, number of strains and relative motions. There is no relative motions between the structure, but the machine having the relative motions. Okay, machine frame, this is an example for structure, and the machines is an example for engine, something, etc, etc. Difference between machines and a structure: the part of a machine moves related to one another, whereas the members of structures do not move related to one another. The machines can move from related to one another. Okay, from for example, the pistons move front and back. The connecting rods moves at an angle at 360 degree, same like that. But the structure do not move. The machine transforms available energy into some useful work, whereas the structure no energy transformed into useful work. The machine can transform the energy, okay, is converted into work, okay, some useful energy at 70 or 80% efficiency, but the structure not to transform. Okay, there is no energy can be transformed by using structure. The link of a machine may transmit both power and motions, with the members transmit only force. The machine can transmit both power and motions, while the member wanted a transmit force only. They do not, uh, they could not transmit power and motions. First, next, invention of mechanism. Okay, just invention of 4-bar mechanism. First, we want to know the invention. What is meant by invention? Just fixing of in 4-bar mechanism. There is a 4 link. Okay, there, for example, we point out A, B, C, and D. Okay, A, B is a first link, and B, C is a second link, C, D is a third link, and D, A is a fourth link. Okay, just it is a each link has a different dimensions and also different shape. First, we wanted to know the what is invention. Just invention is nothing but the uh, fixing of each every link. Okay, first link we can fix first link, and we can give input to first link and output in another point. Okay, just same like that. Second and third and fixing of third and fourth link. It is known as an inversion. Okay. So next, just before you want to know what is meant by Kirchhoff law. Okay, Kirchhoff law is that sum of shortest link and the longest link should not greater than the sum of other two links. Okay, just in 4-bar mechanism, just we wanted to total the sum of dimension, that means shortest and the longest, okay, should not greater than the sum of other two lines. Okay, just we wanted to change, uh, satisfy the Kirchhoff law. Okay, Kirchhoff law, if you wanted to satisfy the Kirchhoff law, just you want to know what is meant by Kirchhoff law. Okay, then only if the 4-bar mechanism is satisfied by Kirchhoff law, then only the output, that means inversion will be work. Okay, inversion of a 4-bar mechanism is beam engine, coupling rod of locomotive, what indicated mechanism. Just it is a beam engine. Okay, this is a crank, smallest link. Okay, this is a smallest link. This is a fixed. Okay, frame is fixed. Cylinder, and this is frame, it is a fixed link 1, and it is a shortest link. This is called crank, that means AB, link 2. Okay, next CB, this is a link 3. Okay, next CE, it is a link 4. Okay, next it is a for it is an application. Okay, a piston rod, cylinder, pistons, etc. It is a the D, this is a frame when the crank is rotated clockwise direction. Okay, clockwise direction at the point of A, thus AB, B tends to in lower position, the C also, the C point also tends to lower position, at the end of E is at higher position. The piston rod and the cylinder is in the top position, maximum point. If the B point is in upper position, the C also in upper position, the E point is reversed to the C. That means to the down position. That means lowest. Okay. If the continuously 360 degree the crank rotates in clockwise direction, The piston moves up and down. Okay, then this is called as a wheel engine. This is an application of wheel engine. The piston moves to and fro motions. Okay, the rotary motion is converted by using reciprocating motion. Okay, next coupling rod of locomotive. Next it is a coupling rod of locomotive. Uh, this is a 4-bar mechanism. That means link 1, link 2, link 3 and link 4. Okay, in A, B is fixed. In this mechanism, the A, B is fixed and link 2 and link 4 is in same dimension. Okay, that means BC and AD is in same dimension, and also DC and AB is in same dimension. Same dimension. Okay, if the we can give input to any link, that means link 4 or link 2. If every mechanism we want to give input to smallest link, okay, link 2 and link 4 is a smallest link, we can give input to link 4 or link 2. It is in clockwise or anti-clockwise. For example, we will give the clockwise direction for the link 2, that means BC. If the link is rotating clockwise direction, okay, next the link 4 also automatically rotated. Okay, link 3 rotated in clockwise directions, it will rotate in similar manner. Okay, it is used in railway. Okay, railway track, that means a railway wheel is it, we can rotate in same dimension. Next, what indicated mechanism. What indicated mechanism is one of the 4-bar mechanism. This is an A is fixed, point B, C, D, E and F. Okay, it is an what indicated mechanism is an example of hand pump. In each and every villages there is a hand pump is used. Okay, this is the same mechanism is worked on that. This is an E, that means lever. Okay, E can move from up and down. Okay, by manual method. Okay, manual method, or it can be automated. Okay, no problem in that. E can move from here to here, that means E dash. The point of D and D dash, if the E point is moved from this place to this place, that means E to E dash, that D can move D to D dash. Same F can move F to F dash. Same that uh, the lever is connected to link 1, that means it is a fixed link. Okay, if the fixed link, it can move up and down, it can be flexible, that means it can be changes. Okay, move the angle, automatically move the angle, but then the piston is moves up and down. Okay, it can be, it is a simple mechanism, it cannot be done with a high speed, it is a low speed. Okay, this is known as what indicated mechanism. There is a link 1, that means it is a fixed, and link 2, this is a link, that means from A to C. Okay, this is an link 2, and the link 3 is C to E, and link 4 is D to F and B to F. Same, both are in same dimension. Both are in same dimension. Work just we can noted as link 4. Okay, and it is a full of applications. Piston, okay, and indicator cylinder, that means fixed cylinder. Okay, it can move from E to E, the water will comes out by using. Thanks for watching and keep learning and growing. Thank you.